It's been a while since I did one of these. I posted a video this morning on this thing down here. I can't really show it because it's taken apart now. But the link to the video is in the description if you want to go see it. If you haven't seen it already, it was about working out a mechanism, a lift mechanism for a new drill press table. Like I talked about this before in a couple of different videos. I was planning on designing and building a new drill press table. And as usual, well, when I make plans for something, I always want to make it so that I'm not having a bunch of hard to find parts or expensive parts. I always want to be using stuff that guys can easily get their hands on or make themselves. So therefore, there are a couple of things that I ruled out when I was going about this. And one of those was the Sprocket approach for driving the 4-threaded rods. Now, I settled on 4-threaded rods because I figure it is the best way to make this work. It'll support the table perfectly, and it'll give me the fine control I want, as in the precision to raise and lower the thing is, like a small amount, and it'll also give me the speed to lower it down rather rapidly. And also you can put the crank for lifting and lowering it anywhere on the thing, depending on how you set up the drive. So those are two givens. I wanted to keep it so that it was made from simple parts, and also it has the 4-threaded rods. Now, the thing I had rigged up here depended on several factors, and it was just that key factor, that key thing that I didn't see before I made it. I don't know what happened there, but first of all, okay, it used rope, and the principle that it's operating on for using rope is what's known as, I can't say it's what makes a capstan work. If you're familiar with the capstan, it's the way rope wraps around a cylinder and how it will grip that cylinder. If you wrap the rope around the cylinder, the capstan, one time, and I'll hold this thing up as an example here, say this is it. One time, it has a grip of pretty good, okay? If you wrap it around another turn, that actually, like for the number of times you wrap the rope around the capstan, you increase the grip that it has on the capstan by like exponentially. So if it has a grip of say 10 with one wrap, it has a grip of 100 with two and 1,000 with three. So nice to have three, but I didn't think I would need it here, so I went with two, and two seemed to be working well. The problem is, of course, that it was, climbing up the capstan, and this is the thing that I simply didn't see when I designed it, and I don't know why. I just kicking myself. But anyway, I posted a video on that, explaining that, and, you get comments from people that, I don't know, they don't listen to what you're saying, especially about the bicycle chain and trying to keep it simple. I wasn't looking for recommendations on timing belts or anything like that. I had one comment saying that you can use, I think I had a couple comments actually, you can use ball chain, and no, I don't want to use ball chain. And then the problem comes with joining that together. That was one of the challenges with this thing, was connecting the ends of the rope to make a continuous belt so that that join wouldn't mess up the thing. It couldn't be a big bump because that would throw things off, I think. And same issue with anything else that's not a continuous belt. Like some people mentioned timing belts for like CNC machines or 3D printers. You have a a problem connecting those as well. You'd have to figure out a way to connect that so that it's continuous, and I can't think of anything. And then if you've got any kind of a timing belt, then you need cogged wheels to match it. And making those, I could make them, but I wouldn't count on anybody else doing it. And like I said, the concept here is to make something that is simple and fairly easy to reproduce for the average woodworker. And that's why I was going with the spools, which are easy enough to make, and the rope, which is very easy to find, and as demonstrated in the thing, fairly easy to join together. All you got to do is melt the ends and put it together, and it welds it up. It's not super duper strong, but it's strong enough to make that work, as demonstrated anyway. So where does that leave me? Well, I came out after I posted the video this morning, and I was messing around with a couple of things. I think I said this before in a video. I think it was talking about one of the electronic projects I did. When I have a problem in front of me, I'm almost like a bulldog. I'll like work at it like a dog working on a bone until eventually I come up with some, solution to it. And I tried to, one suggestion was to make guides for the rope. I got to point out another thing about the thing. See, another challenge with this whole idea is that all of the capstans or the spools have to be exactly the same size. Otherwise, the timing is off. And another thing is the rope has to be an even thickness, of course, all the way through. Although I don't think that that's as big a problem. But it cannot stack up on top of each other. I had another comment where someone said, you can use a concave spool and that would solve the problem because then the rope would kind of fall into it. It will not work because you got a varying run length then. It's not flat like these spools. It has to be flat. So I was working with guides to try to guide the rope so that it wouldn't climb up the spools. That didn't work. I don't know if I could possibly get it to work with a better arrangement, but as it was getting way too complex, so I scrapped that idea. I also, and I posted this on Instagram, I also tried a sanding belt, where is it, right here, that I stripped about a 1/2 inch off, and I put it between two pulleys. That works well, transfers the motion really good, and that gave me an idea that maybe if I have one longer belt, that I could wrap it around the whole thing, and that's what you'll see right here. Try to get the camera looking down on it. And that's a 2x72 belt, an old one that from my shed, that I ripped like a 1/2 inch strip off of it, and I wound it around. And I made those idler wheels to go there. And it works. I'll just try to get it to work here. It works, but I'm not sold on it. Okay, so what I think I'm going to do is go back to one of my original ideas, and that was to use gears. Now, there were a couple of different arrangements for that. One was to have seven gears, like it'd be 1, 2, 3, 1, 2, 1, 2, and they'd all link. And then, the ones in the corner, when they turn, they'd all turn in the same direction. That's the reason why you need more gears, because one would drive the other and the other one would drive that one, and so on and so forth. But rethinking that, well, not rethinking that, but this is another idea that I had from a while back, is because you really want to have the center open, right? So instead of having those 7 gears, I'm going to have, I think, 4 gears, one for each corner, and then one larger ring gear for the middle, so that you'll drive one of the corners, and that will drive the ring gear, and then the ring gear will drive the other three gears, and it would, it will raise and lower the table equally. And a ring gear doesn't have an axle center, of course, but there's a way to rig that up so that you can put bearings in there to catch the rim of the inside of the ring and make it work well. So that's where I'm at right now with this. Even though this thing here, it actually looks pretty cool and it works well, and it'll work even better because like what I have here is really high friction. Basically all of these parts, none of these are on like sleeve bearings or anything like that, like the full bill will. I think I'm actually going to go for sealed bearings instead of sleeves. But there would be very little friction in any of that, and it would take very little effort to turn each threaded rod to raise and lower the table because there's really no load. I mean, when you're pressing down on the table, it's usually stopped. And that brings me to like, what are the advantages? I had another comment asking me about the advantages of doing it this way. Well, obviously, I mean, if you're supporting a table with 4 legs, it's better than having it supported on one big leg that's cantilevered out, which is what the normal drill press is. Also, like I mentioned before, the precision that you can get for raising and lowering, it's not often that I need that precision, but what I find more annoying than anything else with that drill press is that I have to reach around one side to loosen the thing so that I can adjust it, and I have to reach around the other side and turn the crank. And with threaded rods on 4 corners, you'd only have to turn the crank. You wouldn't have to lock it. It would be self-locking, at least to the point where it wouldn't, like you could reliably count on it for like woodworking type activities. I mean, obviously if it was a metal machining type thing, then it would be a different story. You would have to have some sort of locking mechanism. But for woodworking, no, you wouldn't have to have that because there's no way that it would move a significant enough amount down or up, like while you're using it, to make any kind of a difference when you're working with wood. All right, I guess that's it. Some of you are probably saying, well, what happened to the table saw, John? What happened to the table saw? I thought you were going to get back to the table saw after you finish fixing up the shop. And yes, I'm going to get back to the table saw, but I also mentioned this in another video. I don't know if it was here or if it was on Patreon, but I want to get this project knocked out while it's still winter. Like I said in that video, views and attention are higher during the winter because obviously guys got, I guess, a bit more time on their hands, whatever. I want to get this drill press table thing done before I get back to that. Like I said, there's plans with this, and to the best of my knowledge, there's no plans for the table saw. And that may change in the future. I may go back on that and actually make plans for the table saw. I don't know what form they'll be, but there definitely will be ones for the drill press table. And like I said, time of the year, I really want to get this done.